Good day to everyone. May I encourage you to please subscribe, share, and watch the whole video so that at least you will understand the lesson. Now, for our topic today is actually the derivation of the derivatives or the computation of the derivatives of a natural exponential function. Now, when we are going to get the derivative of natural exponential function, we are going to apply the rules that we have in here. If we are going to apply the rule number 1 and rule number 2, it says in here, you can only apply the rule number 1 and rule number 2 if the u is differentiable. Meaning to say, the u in here is actually the exponent, okay, or exponent of the natural number e. Okay, so that in the rule number 1, d over dx of e raised to x is the same as e raised to x. So it's a shortcut. Now notice in the rule number 2, d over dx of e raised to u is equal to e raised to u multiplied by the derivative of the u, which is the same as u prime. Now, so that to further illustrate the problem, we have in here the number 1, okay? In our number 1, okay, it says in here, your function is y is equal to e raised to 2 raised to x. Before we're going to compute for this one or calculate this one, we have to identify the value of the u. Again, the value of the u in here in the exponential, natural exponential number is always the exponent. So our u, for us to apply the rule number 1 and rule number 2, that is for our u is actually u is the same as 2 raised to x. So that notice that we have to get the derivative of the u. So what is the derivative of the u? Your u prime must be 2, okay? So that is the derivative of the u. Now having said that one, we are now ready to get the derivative of y, which is equal to e raised to 2x. Now how is that? That is the same as saying your y prime would be, you calculate the problem, the original problem. What is that? That is the same as e raised to 2x. And it says in here, in the rule number 2, you have to get the derivative of the u. So what is the derivative of the u? Which is 2x. That is the same as multiplied by 2. Now having said that one, the final answer would be y prime is the same as 2e raised to 2x. Okay? So this is already the final answer or the derivative of our number 1 example. To further understand the rule, now let's try to consider example number 2. So in our example number 2, our f of x is equated to e raised to an exponent that is a binomial negative 2x plus x raised to 2. So as you can see, this is an exponent. It has also an exponent again. So how are we going to do that one? Again, there is no hard rule in here. We just try to identify where is the u. Okay, so our u in here is actually, negative 2x plus x raised to 2. It says in the rule that we need to get the derivative of the u. Why? It is because it is considered to be our factor or multiplier. So what is the derivative of the u? We say u prime. U prime now is the same as, what is the derivative? Negative 2. How about this one? Plus 2x. Okay? So that is the derivative. Or we might as well factor out 2 in here. So we have in here that is the same as positive 2 multiplied by negative 1 plus x Okay? Or that can be written as, again, y prime is the same as 2 multiplied by x minus 1. We just try to rewrite it. Okay? So that is the derivative of the y prime. Okay? That is the derivative of the y prime, or the f of x is equal to, no, that is the derivative of the u, which is the same as negative 2x plus x raised to 2. Having said that one, that's the time we're going now to get the derivative of the whole function. So what is the derivative of the whole function? We say f prime of x. Okay? F prime of x. Now what is our e raised to u? Our e raised to u is, of course, the problem itself. Okay? So what is the problem itself? So we have in here e raised to negative 2x plus x raised to 2. Now it says in here multiplied by u prime. So what is your u prime? We have it here, that is the same as, we have in here 2 multiplied by x minus 1. Okay? So we change the enclosure symbol by using this one. Okay? So having said that one, we can now multiply the problem. So what would be the derivative? F prime of x will give you now a result that is the same as bring here in front. So we have in here 2, the quantity x minus 1 e raised to negative 2x plus x raised to 2. Okay? X raised to 2. So that would be the derivative of the problem. So allow me to put it inside the box. So we have in here the derivative. So the derivative of this problem is f prime of x is equal to the product of 2 multiplied by the quantity x minus 1 multiplied by e raised to negative 2x plus x raised to 2. So that is the example number 2. Okay, what about the example number 3? So we have in here the number 3. In our number 3, it says in here, what is the derivative? What is the derivative of g of x, which is equal to e raised to the square root of x? So to do this one, again, always identify the u. Okay? So what is the u here? Now notice that our u is equal to the square root. Okay? The square root of x. So how do we get the derivative of the u? The derivative of the u in here now would be, of course, we have to convert this one into its exponential form. So what is that in its exponential form? U is the same as x raised to 1/2. Okay? Now, having said that one, that's the time we're going to get or extract now the derivative. So what would be its derivative? So we have now in here u prime of x. U prime of x raised to the u prime now is the same as 1/2. Okay, 1/2 x. Okay, raised to 1/2 minus 1. Now, having said that one, we can now have the derivative of the u, which is u prime. That is the same as 1/2 x raised to negative 1/2. Or with that, we have to convert this one into its radical form. Now, what is the radical form? The radical form now would be u prime is the same as 1 over, okay, 1 over 2x, or the square root of x. Okay, so that would be its so this would be now the derivative of the u, okay, which is u prime is equal to positive 1 over 2 the square root of x. Now, having said that one, we are now ready to get the derivative of the whole function. So g prime now, okay, g prime of x, okay, g prime of x is equal to the original problem. So what is the original problem? We have in here e raised to u, which is the square root of x multiplied by the derivative of the u. What is the derivative of the u? We have in here y prime or u prime now is equal to 1 over 2 the square root of x. Okay, so we have this one. So what will be the final answer? The final answer will be now, we have in here e. Okay, we have in here multiply e raised to the square root of x over, okay, 2 the square root of x. So meaning our g of x now would be, okay, so our g of x now would be g prime of x is equal to, that is the same as e raised to the square root of x over 2 the square root of x. So that is the problem number 3. Okay, that is the problem number 3. So for our number 4, it says in here, what is the derivative of y, which is equated to e raised to tangent x? Okay, now again, there is no hard rule in here. Okay, always follow the rule that we have in here, rule number 1 and number 2. And of course, in the rule number 2, you always identify what is u. Okay? Now, in our problem, we have to identify first the u. What is our u? Our u in here is actually tangent. Okay? Tangent x. Now, it says in here, what is the derivative of the tangent x? So, we apply the u prime, which is the same as what is the derivative of tangent. So, if we are talking of tangent, that is the same as secant. Okay? Secant squared. Okay? Secant squared x multiplied by, again, the derivative of x, which is the same as what? So 1 multiplied by secant squared x is the same as secant squared x. So that is the derivative of our u. Now, so that if we have now the derivative of our u, we are now ready to get the derivative of this problem. So we say the derivative now, okay, the derivative of our problem now is the same as d over dx, okay, which is of y will be, that is the same as, what is your e? Our e is e raised to, is equal to e raised to tangent x multiplied by the derivative of the u prime, which is tangent x. What is the derivative? So that is the same as secant squared x. Okay, so that is our derivative for the tangent. After that one, we multiply. Okay, after that one, we multiply. So when we are going to multiply that one now, I will use the y prime. Okay, so y prime now would be, that is the same as secant squared x e raised to tangent x. Okay, so that would be, that is now the derivative of the problem. Okay, so the derivative is y prime is equal to secant squared x e raised to tangent x. So that is for the example number 4. So for our number 5, notice that when we are going to get the derivative of this one, we apply the product rule. Okay, the product rule. Now let's try to recall. Okay, recall. Now what is the product rule? We say that when we are going to have the product rule, d over dx of f of x is the same as is the same as h of x, okay? H of x multiplied by g prime of x, okay? G prime of x plus g of x multiplied by h prime of x, okay? H prime of x. So that is what we are going to apply. So that when we are going to apply that one, let's try to identify where is h and where is g function. So what if I will identify this one to be my h? Okay, so meaning I have to identify my h, that is the same as h of x is equal to e raised to negative 4x. Now it says in here, when I'm going to get the h of x, which is e raised to negative 4x, I have to get the derivative because the derivative will be a multiplier. Okay, so what would be its derivative? So that is the same as h of x is the same as e raised to negative 4x. Now, what would be the derivative of negative 4x? It will give you negative 4. So what would be the h prime of x? It will give you now negative 4e raised to negative 4x. Okay? So that is the step number 1. For the step number 2, we have to get your g function, okay? G function, okay? So what is our g function? G of x is equal to, what is our g function? Sine, okay? Sine 5x. Get the derivative. G of x is equal to, that is the same as 5 cosine x. So that is the derivative of the g of x. Okay? Now after that one, we are now ready to get the derivative of this one. Okay? So how do we get the derivative? Let's try to erase the number 4. Okay? Notice that if we are going now to get the derivative, we apply the product rule. So our derivative now is y prime is equal to what is our h? Our h is this one. Okay, so that is the same as e raised to negative 4x. Okay, e raised to negative 4x multiplied by the derivative of g prime of our g of x, which is the same as 5 cosine x. So 5 cosine x. Okay, it says in here plus. What is your g of x? Our g of x now is sine multiplied by h prime. So what is that? We have in here h prime is negative 4 e y prime is e raised to negative 4x sine 5x. Okay. So that is for number 5. So, what is now the derivative of h of x? So we have in here h prime of x. So we have this one, h prime of x is negative 4 e raised to negative 4. Okay, 4x. So having said that for now, we can now multiply. Okay, so we have in here now following our product rule. Okay, so following our product rule. Now, so that you have to simplify. So if I were to simplify, I notice that we have in here that is the same as, we multiply this one, that is the same as 5 cosine x multiplied by e raised to negative 4x. So what about this one? Multiply. We have negative 4 sine 5x Again, that is e raised to negative 4x. Okay? Now notice that we can have this one to be our final result, but this can be simplified by trying to factor out what is common to them. Okay? So notice what is common is we have this one. Okay? So we can factor out the one. So if we're going to factor out, we might have a result of saying that is the same as e multiplied by 5 cosine x minus 4 sine 5x. Okay, 5x. So we have this one as our result. Or we can put this one in here. So we can rewrite that one by saying the quantity 5 cosine x minus 4 sine 5x multiplied by e raised to negative 4x. So that is our y prime or derivative. Okay, derivative of our problem. Okay, so that is the derivative of our problem. I hope you understand how to get the derivative of natural exponential function. Okay, thank you and more power.